Hello everybody, and welcome back to Space Engine. It's always fun to be here. Where we left off, this ringed planet with aerial life. Because who doesn't love aerial life? My fish tank is probably still noisy. I need to clean the filter. I was going to do that today, but I got completely sidetracked. The shrimp don't care, but I care because it's annoying. The water's actually clean, it's just the water flow is disrupted. So, anyways, yeah, Space Engine, lots of fun. The galaxy is a big place. Or so I'm told. I haven't seen it myself in person. Well, actually, I've seen the actual galaxy from space. The joke ruins itself if I try to explain it. No, it is indeed a big place. Let's go to our first destination, which is actually our only destination that I've recommended. I don't think it exists, according to this. Yeah, are you sure about that game? Because it looks like it was well, let's do an experiment. No? No? Because it looks like it's written correctly. But the question is, maybe maybe my game is different? Like, I have the Steam version, so I don't know what version it is. Well, that's disappointing. The person who recommended me this, they said it looked like a fried meat product. Try it again and see if it is correct, because I'm curious. I want to see this. And I'm always open to more suggestions on place to go and things to talk about. People always recommend places, but they never recommend topics. I don't know why, because I will talk about literally anything, even things I have no knowledge in, like sports. Well, it depends on the sports, really. I mean, like, I'm reasonable at golf. I rock climb. I like squash. Badminton, I'm pretty good at. Hockey, I know pretty much nothing about, despite being Canadian. I mean, I used to ice skate, and, like, I know the basics. I used to play soccer. I wasn't very good at it, but I remember that. I tried softball once. I was even worse at that, and I don't remember any of that. American football, I don't know. How am I supposed to know? We are in the Milky Way, right? According to this, yeah, according to this, we are indeed in the Milky Way. And that should be Andromeda. It most certainly is. That's exciting. Right then, like, if we can look around for stuff. Things to talk about, things to talk about. I've been recently talking about, like, just in general to other people who don't care, a topic that, like, really gets to me. It keeps me up at night. And it's the biology experiments on the Viking landers. I think I've mentioned them before in past episodes, but they always get to me because, in all intents and purposes, they found life on Mars, but never went back to confirm it. And that's so disappointing. Because ever since the Viking landers, there hasn't been a single, like, direct life-finding experiment sent to Mars. Everything since Viking has been, like, geology and meteorology. You know, trying to see if Mars was habitable or if it could be habitable. But they've never actually just looked for life since Viking, which looked for life and seemingly found it. Oh wow, there's 2 moons here with life. I'm gonna guess probably panspermia between the two. If I had to, you know, bet. But we will see. My tea is still too hot to drink. That's disappointing. Because I enjoy my tea. Yeah, because one of the experiments specifically, it was called the labeled release experiment. And what it was a... Basically, they would have a soup of simple carbohydrates and amino acids, like just basic metabolism, like things that bacteria could metabolize, and it would be enriched with carbon-14, which is radioactive carbon. And the whole prospect of it was abiogenic. Uh-oh. I lost that bet. The whole prospect, or the whole concept of it was, if microbes metabolized the soup, they would release carbon dioxide, and the carbon dioxide they would release would be enriched with carbon-14, so it would be radioactive gas, basically, and that would be detected, and you can detect how much is released by how high the counts are per minute of the radioactive carbon-14. It's actually just, like, deceptively simple. It's brilliant. I love it. Okay, cool. 2 separate origins on one place. I lost that bet. That's disappointing. And they tested it on Earth. They used normal soil, and yeah, you get this thing where you'd have this spike in the graph of carbon-14 over time, where it would raise up and up and up and up and up, and then it would plateau once all the soup was, like, nutrients were used up. It would plateau, and then slowly drop off as it decays. Actually, I don't think it decayed, though, but it would at least plateau, and then they'd purge it and try again. And then they tried using sterilized soil, and you would get no results. There was nothing in the soil metabolizing it. It then went to this island off of Iceland that had recently erupted, and it was actually clean, sterile soil that wasn't altered by humans to make it sterile. Like, it was just naturally sterile, and same thing, got 0 results. They then grabbed very sparsely contaminated soil and tried it, and you got a weak result. And it's like, ah, cool. So anyways, they stuffed this into Viking 1 and 2, and they sent them off to Mars. And Viking 1 and 2 were both 100% sterile. Because they were simple and mostly analog, they could be autoclaved in an oven at 111 degrees Celsius for like 4 days. So they were 100% sterile. They were the cleanest things to ever land on Mars. And Viking 1 lands, and everyone's really excited about it, and it grabs some soil and stuffs it into this experiment. And everyone's like, well, now we get to wait and see. And what they noticed was that the count started going up. Like, it started giving a positive result for metabolism. And it did the exact same thing on Earth, where it went up and up and up, and then it plateaued off. So you had basically something in the soil was breaking down the soup and releasing carbon-14. And they were like, well, that's interesting. That's very interesting. Something metabolized, or seemed to have metabolized, the organic soup. So they ran the control experiment, which was they scooped up some Mars soil, and they heated it up to over 100 degrees to sterilize it, and then ran it again. And it got a negative result. Nothing in the soil, in the sterilized soil, nothing, there was no metabolism detected. And that's very interesting, because if it's chemistry, game's frozen. If it's chemistry, that shouldn't have happened. If it was chemistry, it would have happened on both the control and normal. Yeah, the info screen seems to always, like, freeze the game. I don't know what the deal is. I'll get back to Mars here in a second. I just want to see if this will fix itself. I don't think it is. Alright, 1 second. And I'm back. Yeah, I don't know. Sometimes accessing the info screen crashes the game. I am not sure why it just does that. So I'll have to be careful with that. But anyways, where was I? I was talking about Viking 1. So yeah, the first experiment, positive results. The control experiment, negative. So that right there, following the pre-flight conditions for a positive discovery, it met them. It's like Viking 1 had, on paper, discovered metabolism on Mars. Now, there was some thought that they were like, well, maybe the sterilization process altered the chemistry of the soil. Like, what if there was a volatile in the soil that was creating it and heating it up, released it? So they thought, okay, fine. We'll try it again on Viking 2, but we'll heat it up to a much lower degree. And they chose, I think, 50 degrees, which is like 20 degrees above body temperature. So it's not hot enough to kill most Earth life, and it's not hot enough to affect the chemistry of the soil, but they figured that if there was life in the Martian soil, it wouldn't be adapted to that, and that temperature would kill it. So Viking 2 landed, I think, in Chryse or Utopia. I know Viking 1 and 2 landed in Utopia Planitia and Chryse Planitia, but I don't know which one's which. Either way, and it ran the normal experiment, and it also got a positive result. It mixed the soil with the organic soup, and it got a reading. And they were like, all right, cool. And then they ran the sterilization procedure, but they only heated it up to 50 degrees, and then ran it again. Negative result. It didn't, like, whatever was in the soil was destroyed by just 50 degrees. And that was very, very interesting, because if it was chemistry of the soil, heating up to 50 degrees shouldn't have changed the chemistry of the soil, and it shouldn't have changed the result if it was, like, a false positive. But it did. And that made everyone, again, think, well, that's just more evidence that we're looking at Mars bacteria. And they ran it a second time, same result. So, between Viking 1 and 2, we got 2 positive results from separate landers on separate sides of the planet. We got it passed 3 control tests. So it's like it passed control, it passed repeatability, and it passed redundancy. So, by all metrics, it found life on Mars. But Viking didn't find organics on Mars. And because of that, everyone was like, well, if there's no organics in the soil samples, it can't be life. So we have to assume that these detections of life were false positives. And everyone got really disappointed and went, fine, we'll go along with that. But then, in the modern era, we discovered that there actually are organics on Mars. There's actually quite a bit of organics on Mars. What we think happened was when Viking was heating the soil to run it through its samples and all that, it was heating up perchlorates in the soil, which are found all over Mars, and the perchlorates were destroying the organics in the soil before they could be registered. Which is interesting to note, because perchlorates is also very toxic to life. Like, if bacteria lives in the soil, perchlorates are going to kill them. So there is some skepticism there about whether or not life could exist in the Martian soil because of all the perchlorates. But we don't know. But another thing that was of interest here was in Viking 2, I believe? Or maybe 1. I think it was 2. It had some of the soil samples stored in a storage container inside the lander for 90 days, after it landed. And they ran the experiment again with the soil that's been stored. It was in complete darkness and at around 10 degrees, so 10 degrees colder than room temperature. So, not hot enough to really affect the soil in any meaningful way. And they ran the experiment with that soil, and it got a negative result. So whatever was in the soil was destroyed by being in darkness for 90 days at 10 degrees. Which, again, reinforces the idea that it's life. Because some people have thought that there's clays on Mars that might be reacting chemically with the organics to produce these false positives. But in my mind, if it was clays or perchlorates or any of that in the soil, sitting in darkness at 10 degrees for 90 days wouldn't change it. Like, it would still be there in a closed container. But if it's life, like bacteria, that either require sunlight or a certain level of radiation or something, then being inside a metal can for 90 days would kill them. So, again, Viking seems to have found something, or at least a process similar to biology, that is destroyed easily by warm temperatures and darkness. Whereas chemistry doesn't necessarily do that. It can. Like, there's still possibly some explanations in the soil chemistry that could explain the results, but not a lot, because a lot of them tend to fall apart when you look at the other examples of, like, it being destroyed by darkness. Like the only ones that really make sense, like the perchlorates and all that, it can kind of make sense if you heat it up past 100, because maybe it outgasses, and that could, I guess, make sense. But at the 50 degree temperature and the 10 degree temperature, it doesn't make much sense. So that's interesting. And because we've discovered organics on Mars now, that means that looking back at the Viking data, it's actually checked off all the criteria for finding life, including organics. 'Cause we found organics now, so there are organics on Mars. So it's really kind of frustrating because Viking 1 and 2 both had a very strong positive result for life on Mars. And we never went back and checked. Like, these results could have been confirmed or denied by sending more direct life-finding experiments to Mars. And it's been 40 years, like over 40 fucking years, and we haven't sent things back. And it's like, it's so frustrating. So, looking back, there's been in recent years, the last, I don't know, 4 or 5 years, there's been more talk about the Viking data and how, yeah, it's looking like there was a positive result for microbial life, and we need to go back and check, and we need to confirm this because it's kind of an important one. So hopefully we can get a direct life finding study sent to Mars before people go to Mars. And this is a bit of an issue, depending on how hard you think Earth life is, because there's a thought that we can't actually confirm life on Mars anymore because spacecraft that haven't been completely sterilized have crashed on Mars or have been on Mars, and there's been enough time that if life can survive on Mars, it's probably spread all over the planet by dust storms. Now, I don't really follow that line of reasoning because, again, as I mentioned, the perchlorates in the soil are highly toxic to life. It's basically like the planet's covered in antiseptic, basically. So, I don't think that Earth bacteria could survive just, like, on the surface of the planet. Maybe in some of the subterranean areas, but not on the surface. So, I don't think that Mars is contaminated yet with Earth bacteria. Like, I would say that it probably isn't. But if people land on Mars, like, and we start setting up colonies on Mars, then yeah, you're gonna get a lot of contamination. A lot of it probably won't survive. Some of it might. So it's like we kind of have to go and check before we drop people off on Mars. So basically, we have if Elon Musk is successful, then we have maybe 15 or 20 years to confirm life on Mars before we really can't confirm it anymore. Although, if we do find life on Mars after we've colonized it, we could run its genome to see if it's contamination or not, but that's a pain in the ass. So, ExoMars, the rover, I think it's called, like, Rosalina Franklin or something like that. It's being developed by Roscosmos and the ESA, and it actually is going to look for past life on Mars, and some of its systems might actually be able to find current life. Not as directly as Viking, but still. So, there is some hope with ExoMars, and it's going to be launching in 2022. It was supposed to launch this year, but there was some issues with some of the systems, and they decided to postpone it for till the next launch window, which I'm glad they did, because after the issue with the Schiaparelli lander, I really do not want this rover to crash. I want ExoMars to land and look for stuff. So I'm glad they postponed that for 2 years. So that's a good step. I hope between ExoMars and the first humans to Mars, I hope we get a direct sample. Like, what we need to do is send something similar to the labeled release detection experiment, and we need to, like, be sure. We need to check for sure. And one of the problems with this is we can't sterilize our current spacecraft to the same specs as Viking. And that's because they use very delicate electronics. Like the rovers, we can't sterilize those very well because the computers are too fragile. If you autoclave them, it'll destroy them, which is kind of annoying. So what's happening with the rovers is the parts are all cleaned by hand in the clean room, and they're put together. And they actually have, like, HEPA filters basically on the rover. So if there's like in the heating and cooling louvers, there's HEPA filters so that any bacteria inside the rover can't get out unless the rover is physically broken open. So the outside are very clean, but the inside not so much. And because of that, they can't actually directly look for life because there'd be too much risk of contamination. And they can't go to special areas because, again, they could contaminate them. So, what we need to do is build, like, dedicated, just life-confirming probes that are made simply and more analog and can be autoclaved, so we can send them to special zones without fear of contamination. Because, like, we need Viking-level spacecraft just to look for life. They can be cheap, they don't have to do a whole lot, but they have to be largely analog. They have to be precise but simple in their detection methods, and they have to be able to be autoclaved. Because there are some other ideas, like, oh, using CO2, like what CO2, what like deposition to like sterilize, and it's like, oh, you can do this now, but it's like just autoclave. Put it in an oven for 4 days, boom, launch it to Mars. So here's hoping we can manage that, because this literally keeps me up at night, because I sit there and I think, damn it, we may have found life on Mars in the 70s, but we've never confirmed it because nobody's bothered to do it, and it really hurts. It kind of hurts about as much as the WoW signal, knowing that that was probably, or it was very probably, I should say, our first detection of an extraterrestrial technology. But it was probably, if it was probably like radar or leakage, and it'll never repeat, and it wasn't a message, it was an accident. So we'll probably never be able to confirm that one unless it does repeat, which I doubt it will. So it's like things like that that just make me really just like, it's so upsetting. We're getting up to 20 minutes. I should probably end this off here. But before I go, and speaking of the WoW signal, I've been working on my radio telescope, which I mentioned. It's going great. My contact at the university and the observatory where I'm setting it up has been very helpful. And yeah, it's going to be a 24-hour data stream from the telescope to a computer set up, well, at where I live, basically. And it's going to be continuously monitoring it 24/7, all day, every day. Just looking through data, real time, mostly real time, from the hydrogen line, looking for aliens. And that's exciting because that means I can actually do live streams where we look for aliens. I can't steer the telescope. It's a zenith telescope, so it points straight up. So we can see where it's pointing using a star map, but I can't control where it's pointing. Like the Earth's rotation controls where it's pointing. But still, anyways, its whole idea is just to sweep the sky looking for aliens as the Earth rotates. So it doesn't actually do like targeted detections of stars like some do. A future array might, but I'll let you know about that. So that's being worked on, and it's probably going to be finished up, if I can get the funding and stuff correct, by end of this year, early next year, is when, somewhere around then. So next winter or spring is when it's going to be deployed. And if you want to help out with that project, there's a link below to a GoFundMe I set up for it. Every little bit helps. Share it around if you can. If you know people who might be interested in helping out, please do, because this will be a completely public telescope. Like, I'll be using the data all the time, but everyone else is allowed to use it too. Like the university is going to use it as well for their astrophysics students. So although I'm building and managing it, the data is free to everybody. And I even have it set up so if people want to like go to the observatory and hook up their computers to the telescopes and do like interferometry, they can do that. That's perfectly fine. So check that out below if you want to help out. That'd be great. And yeah, if you have other ideas for where you want me to go in the game, let me know, or topics to talk about. I would love that very much. So thank you all for watching. I hope you enjoyed, and space.